Right, welcome to my YouTube channel. This is Atimise Math Academy, where mathematics is being made easy. Today, our topic, we are going to be talking about geometric progression. Geometric progression. Now, a geometric progression, GP, now, anytime in your exam you see GP, it stands for geometric progression. It's a sequence, it's a flow of numbers in which each term after the first is obtained by multiplying the previous term by a constant number called the common ratio. Now, as we teach on, I'm going to teach you how to get your common ratio. Common ratio is very important in this geometric progression. Now, let's talk about basic examples of GP. It is from this basic example I'm going to teach you or explain the definition of this geometric progression. This definition, anywhere you define it, is being noticed and is a standard definition. Now, let's take one example. Basic examples of GP. Wow, this is nice. We have a sequence. What is a sequence? A sequence is a number. When you add a particular number, it gives you another number. That same number you add again, it will give you another number. It continues, just like 1, 2, 3, 4, 5, 6, 7, 8. You see that you keep on adding one number. That number you are continuously adding is called what? The common ratio here. But now the common ratio, as the name implies, common ratio, like this example one, now you have 2, 4, 8, 16, 32. It's not magic. It's a sequence. It's a flow. There is a particular number I multiplied with this first number. Remember, it is multiplication. You multiply the previous. We'll talk about the previous. The first number before this one. Now, the previous of 4 is 2. The previous of 8 is 4. The previous of 16 is 8. So what do we do now? Look at what I'm going to do. I said 2, 4, 8, 16, 32. It continues. This implies that this arrow here, this small letter arrow, is used to donate common ratio. So now, how do we get these two? It is very important in geometric progression that you first of all know how to get your common ratio before you talk about your first term. What is first term? First term is the first number that occur in your sequence. Like this one now, the first term is 2. The first term of this one is 3. The first term of this one is 5. The first term of this one is 8. So to get the first term is very simple. Now, how do we now get our common ratio? Now, let me take this first one. Look at, we said we should, there is a number you continue multiplying and you'll be getting the next one. How do we get it? Now, this is what you're going to do. You are going to use the previous one. Like, for example, now, I will always use the next number to get my common ratio. For example, like this one, I want to use 4. If I want to use 4, the previous one here is 2. If I want to use 8, the previous number here is 4. So let me just give one from that one. How do we get these two? It's very simple. Now, we have 4 divided by 2. Observe something here. 4 divided by 2, I'm talking about this 4 divided by this 2, or 8 divided by 4, or 16 divided. We want to get that common number that we use to multiply each of them to get the next number. That is what I'm trying to do, to get our common ratio. So what do we do? 4 divided by 2, you see that you have 2. Now, the previous number of 8 is 4. So you have 8 divided by 4, you have 2. The previous number of 16 is what? Is 8. So 16 divided by 8, you have 2. You see that 2 now reoccur. Occur. So that is why I take that reoccurrence of that number as what? As 2, which is my what? Common ratio. Very easy to get. Now let's come to this example. Example what? Example 2. Now the common ratio of each sequence differs. It differs in different what? Sequences. Like the common ratio of this might not be the common ratio of this. Now let's observe something. We have 3, we have 9, we have 27, we have 81. Now check. Let's go to that number 1 again. If we say the common ratio is 2, now let's multiply, because we said when you multiply the previous term by a constant number. Now the constant number is this common ratio, which is this 2 now. Now multiply this first one. 2 times this 2 will give you 4. 2 times 4 will give you 8. 2 times 8 will give you 16. 2 times 16 will give you 32. You continue multiplying until you get these 3 dots you see here. It means it's continuous. So you continue getting the numbers continuously until what? Infinity. So that is how we get for this sequence. Anywhere you go all over the world, the sequence for this, the common ratio for this sequence is 2, fundamentally. Now let's go to the number 2. Observe, if you use this 9, remember, the formula is each stem divided by the previous. Divided by the previous. Divided by what? By the previous stem. This is the formula. So as we go further, I'm going to elaborate more on it. Okay? Now watch. This is 3 and 9. Now we skip the first term, come to the second term. We have 9 divided by 3. You observe that you have what? 3. 27 divided by 9. You observe that you have 3. 81 divided by 27. You observe that you have 3. So that 3 now is a constant number. So it is called the common ratio. I told you, like what the definition says, common ratio is denoted as what? Small letter r. Now, let's come to this one. When you continue having a frequent number that is the same, like this one, you have 5, 5, 5, 5, 5, continuously. You observe that if I use this 5 divided by this first term, it will give me 1. 5 divided by 5 will give me 1. 5 divided by 5, it will give me 1. So it will continuously give me 1. That is why I say the common ratio here is 1. Observe. So if I have 4, 4, 4, 4, it will give me 1. If I have 2, 2, 2, 2, it will give me 1. If I have 3, 3, 3, 3, it will give me 1. One example is equivalent to solving plenty problems. So like this one now, if I see again anywhere that I see an occurrence of the same number, my common ratio is always 1. Now let's come to for fractional ratio. What happens if you have fractional ratio? What happens if your final answer or your common ratio will not become a fraction? This is how it works. Now watch this one. You observe that the first term is, if you check very well, as it goes down, you observe that it's getting smaller. It's getting smaller. So you may likely have a fraction as your common ratio. Now let's observe. We have 8, we have 4. If you bring the term, because you always take the next number divided by the previous number. Now the next number of 8 is 4. You take 4. Are you observing? You take 4 divided by 8. Divided by 8. 4 goes to itself is 1. 4 goes to this is 2. You observe that you have 1 over 2. So we have a fraction. So most of the common ratios you have is basically a fraction. So that's why I say for fractional ratio, how do I get it again? You divide this one by its previous one. When you divide by its previous one, you have this fraction. Just imagine you want to divide 2 by 4. You want to divide 2 by 4. You observe that 2 will go to 4 one time, right? 2 will go to 4 2 times. Let's see that we have 2 over 4. 2 will goes to itself 1, 2 will goes to 4 twice. So you still have what equals to 1 over 2. Okay, since I have 1 over 2 here, I have 1 over 2 here, it becomes an occurrence. So that is why I say my common ratio here is 1 over 2. So I believe it is now very simple for us to get our common ratio, because as we solve further, if you don't know how to get your common ratio, it will be very difficult for you to find your nth term, for you to find your sum, for you to find your infinity of geometric progression. Now let's see this other one. You have one whole number. You have 1 over 3. If you check it very well, let me try this. Let me solve this. Let me solve this and see. You have 1. First of all, take the previous or 1 over 3 divided by what? Divided by 1. Divided by 1. You observe that. You will end up having what? Is equals to what? 1 over what? 3. You have 1 over 3. Because if this whole stuff is divided by 1, you still have what? 1 over 3. The same thing you do here now. If you have this divided by this, you observe that this 3, how many times can 3 go to 9? It will be 3, right? 3 times 3 is 9. So you still have what? 1 over 3. So that is why the common ratio here is 1 over 3. What happened for negative ratio? Negative ratio. Negative ratio. Like for example now. For example, if you have your final ratio to be negative. Now if I have the first term to be 2 and my previous one to be negative. You already know that by the time 4 is divided by 2, you have minus 2. By the time 8 is divided by minus 4, you have minus 2. By the time minus 16 is divided by 8, you have minus 2. So the common ratio, the occurrence, the constant that you use to multiply this to get this to get this is minus 2. Let's check this one again. As long as there is negative present, most of the time, your common ratio will end up having negative what? Frequency. Having negative what? Sequence. Okay? Now, let's come to this side. You have minus 3 divided by 6. You will end up having what? Minus 2. So, at this point, we discover that to get our common ratio, we must calculate our what? We must first of all identify the common constants. For us to identify the common constant, we have to divide the term by the previous number. Or divide the term by the previous number, we always have our common ratio. By the time you use that common ratio to multiply the first term, you will get the second term. Use to multiply the second term, you get the third term. Use to multiply the third term, you get the fourth term, and it continues. So at this point, if in case you have any question, you can drop it on my comments below, and anything you don't understand, I will put you through. So thank you very much. Also watch my YouTube channel, Atimise Maths Academy online. Thank you very much.